So I my marker there's no refuge, so I want to use pen and so let's just quickly do one or two things now. For difference equation, we know that for ODE like dy over dx, let's say if dy over dx equals to 2x, something like that, or let's say ax, this is like a continuous change in values, like a continuous change in variables. The divide yes we know very well, but we have some variables that they don't change continuously, they change in steps. So that's the reason why there is something we call difference equation. They don't change continuously, they change in steps. So in that case we have an equation for them, that which is like 1 y 1 plus y n plus 1 minus yn, let's say equals to 5. Do you get? So which means this value increased by 5. So it means this value increased by 5 when n increased by 1. You can say yn plus 1. So when our n increased by 1, the fact that this is equals to 5, it means this value increased by 5. This is for the continuous change. But for difference equation, like step, it can change in step, like like how can I put it now? Population in a year. The change is in step, not continuously like OD. Do we get that? So now, for instance, if we have equation like this, it means this value changed by 5 when n increased by 1. So we have our change in yn equals to yn plus 1 minus what? Yn. For using this analogy, this is our change in yn. So change in yn equals to this minus this. So let's say for instance, if we have yn equals to n square, and we are asked to find our change in yn. If yn equals to n square, if we are asked to find our change in yn, then we have our change in yn to be equals to what? Y I'm coming. It's going to give us n plus 1 all square. Our yn equals to n square. If yn equals to n square and we have this equation for difference equation, and we have to find change in yn, so yn plus 1 will give us n plus 1 square minus yn minus n square. So our change in yn is going to give us n square plus 2n plus 1 minus n square. This cancel, that means our change in yn equals to what? 2n plus 1. So that's that for that. Now let's talk about the shift operator. Shift operator, and that's letter E. So our shift operator EYN equals to yn plus 1. Take note of that. This means the function is shift by one step forward. So let's say for example, if yn equals to n square, then let's find our shift operator. Just like we find change in n when yn equals to n square. So if yn equals to n square, let's find our shift operator. And we know that our shift operator is equals to what? Yn plus 1. So that means our shift operator will give us n plus 1 square. Since we say if yn equals to n square, we are just giving an example. So this gives us n square plus what? 2n plus what? Plus 1. So this our what? This our shift operator. And there is a relationship between shift operator and what's it called? And forward difference operator. This is what we call forward difference. Forward difference operator is known as delta. Delta. And shift operator is known as E. So the relationship between them is E equals to 1 plus delta. And let's prove it. We are going to prove it now from this idea. Yeah, EYN. We want to prove this in case we are asked. EYN equals to yn plus 1. And we know that change in yn equals to what? Yn plus 1 minus what? Minus yn. We discussed this earlier, right? Now let's make yn plus 1 the subject of the formula. So we have yn plus 1 equals to what? Change in yn plus yn, right? So since EYN is yn plus 1, that means say we can now say EYN, since these two are equal from here, and this is equal to this, you can see from this equation we've discussed that earlier, change in yn equals to this. Know that. So here we have EYN equals to what? Change in yn. I'm trying to check something. Change in yn plus what? Plus yn. So which is equal to change. Now can you see that which is equal to change? If you bring out change plus 1 into yn, no, this times this you get this times this you get 1. So here we can conclude our EYN from here. Sorry, this y is big O. EYN equals to change our what was it called now? I'm forgetting. What was the name of this guy? Our forward difference operator, which is delta, plus 1 into yn. Are we together? Like, this is just simple arithmetic. Just get what I did there. So here, yn cancel yn. And we can now prove that E equals to D plus 1, delta plus 1, just like I wrote here. So that's just the proof. You can just back the video and calm down and watch. Now let's solve an equation now. Let me think of an equation. Maybe if we have something like okay, let's say y, or before then, let's see order of a difference equation. Before then, order of a difference equation. The order of a difference equation is known as the highest minus lowest. So if you are given an equation like yn plus 2 minus 3yn plus 1 plus 2yn equals to, this y is big O, yeah, equals to 0. So the order will be the highest, which is n plus 2. The what's it called? The lowest is n minus n. The lowest order here is n, the highest is n plus 2. Just like derivative, second order, first order. So this n is like, do we get that now? So here, n cancel n. So the order here is what? The order is 2. The order of this difference is 2. Do we get like second order? Do we get that now? So now let's solve this question. Let's say we have that same question. Let's solve it. Let's find the solution. Let's solve it. We have yn plus 2 minus 3yn plus 1 plus 2yn equals to what? Equals to 0. What do you say? So what we are going to do here is that let yn be equal to r raised to power n. You can like to put anything just to transform this equation to something that can be solved using quadratic or any method to find your. So if you say let yn equals to r raised to power n, so here, since yn is r raised to power n, yn plus 2 will give us what? R raised to power n plus 2. Do we get? Minus 3r raised to power n plus 1. Do we get? Plus what? 2r raised to power n equals to what? 0. I think that's clear now. Divide everything by r raised to power n. Divide everything by r raised to power n. Don't forget r raised to power n plus 2 is same as r raised to power n times r raised to power 2. So if you divide everything by r raised to power n, this will give us r squared minus what? 3r, right? Plus 2 equals to what? Is 0. So if you solve using quadratic equation, we get r into what? We get r squared minus 2r minus r plus 2 equals to 0. So this will give us r into what? R minus 2 minus 1, r minus 2. So we have r equals to 2, r equals to 1. So this is our auxiliary equation. This is our auxiliary root. We have two distinct roots. And don't forget, this is just like ODE. The idea of ODE is the same thing, like, but in this case, if you have this one now is just like, if you have like how can I put it now? If you have like n plus 1, this like referring to OD, n plus 1. If you say n plus 1, it's just like first derivative like first order. You see n plus 2 is like second order. If you see n, just normal n, there is no derivative there. So it's just like the idea. That's why we are getting order of 2 here. Do you get that now? So now if we want to solve, write our complementary solution. You know our complementary solution? So we put C. You know, unlike OD, we say YC, but this one we can say YN raised power C. If you want to write particular solution, we say YN raised power P. So our complementary solution now will give us C1. So that's C1. What's our first root? 1 raised to power N. This one is power now. Plus C2. What's our second root? 2 raised power N. So it gives us C1. You know, 1 raised power N, since N is natural number, is C1 plus what? C2, 2 raised power what? N. Because this homogeneous is equal to 0. So these are our complementary, like this is the solution to this, our complementary solution. So please take note of that. So because there is a distinct root, now we still follow the idea of ODE. If there is no distinct root, maybe we have 2 in 2 places. If you have 2 in 2 places, this will be C1, 1 raised power N, plus C2, N, 2 raised power N. Just like OD, that if you have distinct root, we add X to one of those constants. So it's still that same idea. So but since there is a distinct root, the roots are not the same. So this is just your final answer. Let me see another question. Divide the X. That second question tó wà ní past question, kí ló ní ká solve ń bẹ̀ tó wà lójú bọ́ọ̀dì? That change in y equals to kí ló ní ká solve ń bẹ̀? So let's see another one. If you have, where's the question? Okay, if you have yn plus 2 minus yn plus 2 minus 3yn plus 1 plus 2yn equals to 3 multiplied by 2 raised power n. No, this is just like the same question we did, but this one is non-homogeneous. The first one is equal to 0, while this is not equal to 0. But to first find our auxiliary equation or our complementary solution, you know, we still get the same thing. Our yn raised power c, our complementary, is going to give us what we got earlier, c1 plus c2, 2 raised power what? N. Now let's find our particular solution. Our particular solution, yn raised power p, is going to give us it's going to give us this. We are going to have this 2 raised power n, but there's going to be what? A constant. Do we remember? It's just like ODE. Like this is going to be equal to this, our particular solution. Now find, in ODE, now find y prime, yp prime. But this one will now find yn plus 1 instead of y prime. Do we get? So this will now be a into 2 n plus I'm sorry, I'm coming. Something is missing here. Something is missing. Yeah. I'm coming. Something is missing. Okay, this is it. In ODE, if you write your particular solution to be equals to this, but this carry constant. If what you have here is in your auxiliary, your root. No, we have 2 in the root. So which means we cannot leave 2 here. I don't know how to put it. Maybe you should go and watch our video on that ODE. There are cases that if it's equal to trig, maybe we have sin x here. And that sin x is already in our auxiliary equation. We have to multiply by x for this particular to make sure that what we have in this particular is not equal to whatever we have. Even if we multiply by x, okay, let me put it this way. If you have sin x, a sin x plus bx sin x. Now, if this is our auxiliary, and for our particular, we say our y particular equals to, let's say, a sin x. Do we get? Now, we can see there is a sin x in our auxiliary, so this must not be a sin x. We have to multiply by what? X to change it from that. And if we still multiply by x, we are still going to get ax sin x. So x sin x is still in our auxiliary, so we need to multiply by x again to give us s squared. So we must not get the same equation in our particular that is in our auxiliary. So in our auxiliary now we have 2. So and here we have 2. So we have to multiply by what? N. We go and watch the video we did so you understand what I'm saying. So here our YNP equals to what? AN 2 raised power what? N. That's our YNP. That's our part. Now our, if you like ODE now, if we want to we differentiate, we find our YP prime. But this one we find our YN plus 1 particular. So it's going to give us AN. So we have AN plus 1. Then we have 2 raised to power what? N plus 1. I hope this is clear. So here we now have what? We now have AN plus 1. 2 raised power N plus 1 is same as 2 raised power N times 2. So this will now give us 2A N plus 1, then what? 2 raised power what? N. This our like our Y prime in OD, but here is N plus 1, like first order. So now if we want to find our Y prime prime, we now find Y particular N plus 2. So this will now give us A into N plus 2, 2 raised power N plus 2. Do we get? So this will now give us A into N plus 2, 2 raised power N dot 2 square, which is 4. We now have 4A N plus 2, 2 raised power N, which our Y prime prime, just like Y prime prime in ODE, but this is YN plus 2. So now this YN plus 2 and this YN plus 1, we now substitute it to our equation. The original question is YN plus 2 minus 3YN plus 1 plus 2YN equals to 2N, right? Now what's our YN plus 2? That's 4A N plus 2, 2 raised power N minus 3. What's our YN plus 1? 2A N plus 1, 2 raised power N plus 2YN. What's our YN? Don't forget our YN is this. These are our YN. No, we have to multiply by N, and I've explained that. So our YN is AN 2 raised power N equals to this. So here, let's divide everything by 2 raised power N. Equals to this. If you divide everything by 2 raised power N, we have 4A N plus 2 minus 3 times this is 6A N plus 1 plus 2AN equals to what? Equals to 3. Are we together? So here now, what are we going to do? So here we have, we are going to open the bracket. 4AN plus 8A minus 6AN plus 6A plus 2AN equals to what? 3. 4AN plus 6AN, we have plus 2AN. So this cancel this. No, minus 6AN. 2AN plus 4AN, 6AN, we cancel this. So what do we have? We have 8A plus 6A equals to what? 3. So we have what? We have 14A equals to 3. So A equals to what? 3 over what? 14. Is that so? So our A is 3 over 14. So what's the next thing I'm coming? Oh, I think we are done. Don't forget our Y particular equals to AN 2 raised power what? N. And what's our A? 3 over 14N 2 raised power N. I have to lie. What do you get for that question the other time? 3 over 2. Me, I'm getting 3 over 14. No? Over 2. My own is over 14. Yeah, I got all those other parts, but I'm getting over 14 here. Let me check again. This I'm coming. This should be over 2. This should be over 2 if you follow the order very well. So our general solution now, YN general, it now give us particular plus complementary, just like ODE. So we now add this one to our complementary here. But this should be over 2. Let's check, please. This should be over 2. Let's check. There's a mix up somewhere. 4AN, 8A. I can't figure it out. But if you understand those ODE, there's no, we are just rushing. So we just want to make sure that people just understand what we are doing. So please, the basic idea, go back to it and just understand. Thank you.